We are actually given the rule and we want to translate a figure in the coordinate plane. So for this first one, I have quadrilateral ABCD has vertices as such, and I want to find the coordinates of the image after the translation. So to do this, I'm just going to start with my first vertex A. And so to translate it, I'm just going to follow exactly what these rules say. And so again, when I'm translating, I want to make sure I'm going to use that prime notation. So now this is A prime. And it says I'm going to add 3 to x. So remember, x is my first coordinate. So I'm going to have negative 1 plus 3. And then I'm going to subtract 1 from my y coordinate. So I'm going to have 2 minus 1. And so after I do that, I get negative 1 plus 3 is 2. And 2 minus 1 is 1. And so I'm just going to keep repeating that for every single one. And so my b is negative 1, 5. Now since I'm translating it, I have b prime. And so I have my x coordinate plus 3. And then my y coordinate is 5, and I want to subtract 1. So negative 1 plus 3 is 2. 5 minus 1, and I get 4. Now I'm just going to keep repeating this process. So now I have c is at 4, 6. I'm translating it, so I get c prime. And so I want to add 3 to my x coordinate, so I want to add 4 plus 3. I want to subtract 1 from my y coordinate, so I have 6 minus 1. And so I get 4 plus 3 is 7. 6 minus 1, and I get 5. And my very last one, again, I want to add 3 to my x coordinate, subtract 1 from my y coordinate. So 4 plus 3, I get 7. 2 minus 1, and I get 1. And so this is my answer. And so I could actually go ahead and graph these. I could graph all of these points and then all of these points to see how my figure translated and moved into a different part of the coordinate plane. And so, as you notice, I added 3 every single time to my x, and then I subtracted 1 every single time to my y. Okay, go ahead and pause the video, and I want you to try that next one on your own. Okay, so these are the answers that you should have gotten. You should have gotten that r prime is 3, 4, s prime is 6, 4, and t prime is 4, 7. Okay, so that brings us into some vocabulary. So all of these translations are a rigid motion, and a rigid motion just means it's a transformation that preserves size and shape. And so we saw that with the Mona Lisa. When I translated it, it stuck the same size and it also stuck with the same shape. It was the same exact thing. And so a congruence transformation is just a rigid motion or a combination of rigid motions. We call those congruence transformations. And the translation postulate tells us that a translation is a rigid motion. And then we also get from the composition theorem, which we'll do some compositions in the next video, is that the composition of 2 or more rigid motions is still a rigid motion. And so that's what that's saying is if I go ahead and move my Mona Lisa up, but then I also decide to move my Mona Lisa to the left, it's still going to be a rigid motion. It's still going to be congruent. And just a reminder, congruent figures are 2 figures in which a rigid motion or a combination of rigid motions maps one of the figures onto the other, and they have the same size and shape. So if I was looking at 2 figures, if I went ahead and translated them and so they're on top of each other, they'd be congruent if I see that they're the exact same. Okay, that's it for this video. You can go ahead and move on to the next one where we will be forming a composition.